everyone. My name is Kandyce Young, and I am with the Data Security Standards team at the PCI DSS.
And I'm Jake Marcinko. I'm also with PCI DSS.
And today, we're going to talk about some implications of infrastructure as code and within the context of PCI DSS.
And I'll be discussing how infrastructure as code can be implemented in real-world scenarios, along with PCI DSS controls to enhance security. I'll also be providing practical guidance for assessors on how to validate infrastructure as code.
So PCI DSS sets the requirements needed to protect environments that store, process, or transmit account data, or that can impact the security of account data.
And infrastructure as code is a modern approach to managing cloud-based computing and network infrastructure via tools and machine-readable config files. Leveraging infrastructure as code helps organizations automate infrastructure management, allowing for greater consistency and control over network and computing resources. This aligns very well with PCI DSS.
And here are the differences between traditional configurations and infrastructure as code documents. Within traditional infrastructures, hardware configurations are typically updated manually at the console of each device, often one at a time. But the issue here is that when devices are updated separately, it's not really scalable, and it's a high likelihood that there are going to be some misconfigurations.
And as we will see, infrastructure as code offers several distinct advantages over traditional infrastructures. It uses code and tools to manage infrastructure by processing machine-readable code that is created once, modified, and then replicated many, many times. This brings consistency, repeatability, and automation to infrastructure management.
So showing here what we talked about on the last slide, a traditional deployment includes the engineer configuration files, manually applied to a single component, and then repeated for each additional component.
So in infrastructure as code, entire environments are represented in a document and are stored on cloud-based version control systems or repositories. There's also a processing mechanism, we'll call it an engine, that's connected to the repositories, and it's used to process the documents to build out system components in a targeted cloud environment. Parameters can also be used to facilitate things like scaling, creating dev or test environments, and resizing components and resources. Now we're going to look at a couple of different scenarios to see how PCI DSS scope is affected by the use of infrastructure as code.
So this shows how the scope for a traditional network architecture, a building with computer equipment and a firewall between the environment and the internet. The gears, which you'll see on several slides, are here as a reminder about all the processes that must be in place to manage the various environments. The orange border that you'll see is what defines the CDE and connected to systems and the scope of the environment. This diagram shows that the organization is still managing most of their component devices in-house, but they are using a cloud-based code repository to store system configuration files. Oh, and there are several engineers there working remotely. They have access into the organization's network and into the cloud code repository. All of this is in scope for PCI DSS. Scope validation involves regularly checking that all of the relevant components and personnel are included in scope.
And it's important to remember that this also includes engineering endpoints, as you likely have copies of code repositories on all engineering endpoints. Ensuring that every endpoint is secured using PCI DSS controls helps prevent unauthorized access to and modification of system components that could lead to potential breaches. Now we're going to look at an increasingly common scenario where all of the computing resources are in the cloud and all the staff are working remotely. The system configuration repository is also in a different cloud environment. All of this is in scope for an organization's PCI DSS assessment.
And it's important to remember the geography of the environment. The different cloud elements may exist in different assessor regions. So now let's look at how system deployments work in traditional versus IAC environments. The processes in IAC are similar to the steps for a traditional network architecture. You set the configuration standards, you get management approval, determine the network architecture, develop or code the actual configuration script, go through the organization's change management, including approvals and testing. Finally, you deploy the code to create the device in production.
In the engineering and deployment phases, it's essential that you test the resulting system components generated by infrastructure as code document processing. Peer review is not enough. Remember, this isn't a programming activity. There are running configurations in the form of system components. Making sure that moving to an infrastructure as code environment doesn't dilute your change records. In infrastructure as code, change management is often not managed as effectively as in traditional approaches. Well-defined processes are essential, but let's not forget, one benefit to infrastructure as code is it makes rollback to a previous version much easier.
And this shows the change loop. So every time you make a change to infrastructure as code, you've got to repeat the steps. To re-architect it, modify the existing code, go through the change management and testing processes, and then deploy it, just like you would for a traditional network. So time to put Jake on the spot here.
Uh-oh.
So an organization is launching a new externally facing API to transmit and process cardholder data. This is the first time the organization has implemented infrastructure as code, and the first time they've implemented an API for cardholder data processing. So the organization already securely handles cardholder data and has undergone a recent PCI DSS assessment for those systems and services. So the focus of this exercise is really to identify the applicable PCI DSS requirements for this new API. The analysis will cover both of what it means for infrastructure as code and CDE components. So Jake, the first implementation of an infrastructure of code environment, which are the relevant PCI DSS requirements here?
Yeah, so we're going to talk about two distinct things. First, we're going to talk about the infrastructure as code systems themselves, and then we'll talk about the actual CDE that's generated through infrastructure as code. So the infrastructure as code components are going to bring in things like policy and process changes, which are requirement one, as infrastructure as code introduces new networking infrastructure. The new infrastructure as code components are also in scope for requirement two. Implementing infrastructure as code is a significant change, so requirement 6 is applicable. Likewise, access requirements will need to change to protect system components from non-infrastructure as code changes, so requirements 7 and 8 are applicable. The infrastructure as code components also need to be logged and tested, so 10 and 11 are applicable. And then there's also a scope change that needs to be recorded for 12.5, plus if you're using a cloud repository solution, that's a new service provider for 12.8. The addition of infrastructure as code is going to add more assessment time too initially to evaluate the management of change processes and the associated documentation. It's often assumed that implementing automation and things like infrastructure as code will save you assessment time, and that's true, but initially it is going to add more time to the first assessment.
Jake, now let's focus on the relevant PCI DSS requirements for the CDE components that have been brought online via the infrastructure as code documents.
So again, from this point, it's the same as the previous scenario. Requirement 1 for the network, requirement 2 for the API components, and requirement 4 for secure traffic. Then we have requirement 6 for the development of the API and the significant change. Requirements 7 and 8 for access to the new components. Requirement 10 for logging and monitoring of components supporting the API. Requirement 11 for testing. And finally, documenting the scope for requirement 12. Now, the big issue here is governance processes must adapt to using infrastructure as code. But in doing so, these do become a robust control. So that help to ensure that the infrastructure remains secure and compliant along with all of the expected benefits of infrastructure as code.
So now that all the infrastructure as code components have been absorbed into the scope, is it true that the controls will be in place for any future management using IAC?
Why, yes, Kandyce.
Well, Jake, anything else to consider when assessing such a situation? What if the repository is cloud-based? Would you need to address a service provider element there too?
So that's a good point, Kandyce. Scope is a major consideration because adding infrastructure as code will add new system components to the in-scope environment. Access controls will also certainly be affected, as you need to ensure that traditional infrastructure management processes are not used to manage infrastructure as code systems. It's also important that access controls are considered to be in scope. Any introduction of a distributed control system may expand PCI DSS scope, as any cloud-based platform that enables infrastructure as code methods are now service providers who can impact the security of the CDE. As I mentioned before, also engineering endpoints where copies of cloud configurations may now reside, those are also in scope. So be mindful if you want to extend the use of infrastructure as code to other system components. You will need to address the system configurations, policies, and procedures, but this is all very manageable.
So would this be considered a significant change?
With traditional hardware-based environments, numerous parties are often involved in making changes to the infrastructure, which usually has operational procedures associated with it. And with infrastructure as code, new components can be represented in a single document. Therefore, it is essential that infrastructure as code change management not only account for the tooling and associated processes which are now in scope, but also the document itself. Changes to the document can have significant impacts to the infrastructure that's deployed, and that could result in a significant change to the CDE scope.
So the same requirements that apply to traditional network configurations also apply to infrastructure as code. One must develop configuration standards, create policies and procedures related to how you'll manage those infrastructure as code components, and also implement the configuration settings. The assessor will have to review all of that.
So why isn't infrastructure as code explicitly mentioned in PCI DSS? Well, it's because it's a workflow technique as much as it is a tool for standardization and assurance of system configurations, which is why it isn't explicitly mentioned. Remember that the processes, applications, and services enabling infrastructure as code are equally in scope and therefore need to be assessed as part of the process. This means infrastructure as code assessments will take more time initially, but as I mentioned earlier, that will improve over time.
So governance controls are essential. It helps ensure that the infrastructure remains secure. It's also important to make sure that the relevant policies and procedures are in place.
And distributed version control systems are almost always present in an infrastructure as code environment. I would recommend entities leverage the features of these technologies to support things like change management, access management, and workflow management processes, as well as any automation that might be part of the solution. And again, these align very well with PCI DSS.
So change controls are particularly important aspects of infrastructure as code governance. The testing processes for development activities versus infrastructure document changes must be different. Peer review for infrastructure as code documents can be performed, but it's important to test the resulting system components as well.
In infrastructure as code, administrative actions are automated. Performing manual administration of infrastructure as code components is a recipe for disaster, as the systems within the environment would likely become out of scope or out of sync with each other. Ensuring that only the right people that can access repositories and documents is equally important. Having document access is like granting admin access to system components. Both need careful consideration, and they should be implemented in a manner that's compatible with PCI DSS requirements.
So some final considerations about infrastructure as code. Cloud deployments using IAC bring flexibility to multiple environments. This brings significant benefits to assuring your configurations are consistent, but which is a bit more difficult to achieve when you're using costly hardware. Make sure your configuration is targeting the right environments at the right time, and that you include engineers, network administrators, operations, and security personnel.
And like really any software, infrastructure as code engines are constantly changing. They're constantly being updated. And we're seeing occurrences that an unchanged infrastructure as code document processes today produces an entirely different result than when it was originally created. And this highlights the importance of testing the target environment. Continuous security measures like ASV scans and penetration tests are the key to maintaining any environment. It's essential that the triggers which invoke the measures continue to be triggered for anything implementing using infrastructure as code techniques. Change management plays a huge role in identifying these triggers.
So updating processes is important, given that you may not have the safety features you had with traditional infrastructure. Executing an infrastructure as code document without appropriate governance could have a significant impact.
As you transition into infrastructure as code, ensure that moving to this workflow doesn't diminish controls that were previously available in traditional infrastructure.
Make sure that you test your infrastructure as code deployments elsewhere before production and review the actual system components. These components are live at the point that the IAC document is processed. So if you haven't already tested, you could prevent, or you could put your production environment at risk in a split second. Infrastructure as code integrates infrastructure management with automated, consistent, and scalable methods. PCI DSS provides controls to secure your infrastructure, whether it's cloud-based or hardware-based. These controls apply in all environments.
Compliance with PCI DSS ensures the security and integrity of cardholder data. Therefore, it's important that using infrastructure as code doesn't erode all this hard work that you put into maintaining PCI DSS compliance. The documented scoping information in requirement 12.5 is a fantastic resource when considering a move to infrastructure as code. Change management processes in requirement 6.5 are also critical and must be more sensitive to the types of changes that can be introduced through infrastructure as code document updates. Leveraging infrastructure as code rarely shortens an assessment, so assessors should ensure that appropriate review time is allocated to enable a thorough review of infrastructure as code components and processes. An assessor should also ensure that infrastructure as code components are not being configured directly. This is not application program. This is bringing system components online, and document configured changes must be handled with care.
But if you have questions about PCI DSS and infrastructure as code, Jake and I will be around today and tomorrow to answer some questions. As well, we've recently published a special interest group guidance document, PCI DSS Scoping and Segmentation Guidance for Modern Network Architectures, and it includes components about infrastructure as code in there. You can find that in the document library of our website. As well, we have a PCI Perspectives blog that you can subscribe to get the latest updates. So thank you so much for all of your time today, and have a good rest of your day.
Thanks.